Hi, today we'll continue our journey with the C language. There are already 5 videos, please watch them. Today we discuss about the bitwise operators, that is internal to the hardware, how C language operators can be used effectively with the computer hardware. Everything is zeros and ones, binary digits. So with C language we are trying to manipulate the data into the computer. Each bit corresponds, it operates on the operands, corresponding bits. There are about 6 types. First one is AND, OR, exclusive OR, right shift, left shift, NOT. So regarding the AND bitwise operator, both bits of the both operands, if they are 1, then the result is 1. For example, operand 1 is 6, operand 2 is 9, and operator, see, 6 in binary 0, 1, 1, 0. This is a decimal. In binary 1, 0, 0, 1. So when you execute this statement in C language, this is what happens. 0, 1, 1, 0, the bitwise operator, and 1, 0, 0, 1. So if you see the corresponding digits 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1. When it's a 0 and a 1, it will be 0. 1, 0 is 0, 1, 0 is 0, 0 and 1 is also 0. When both are 1 only, it will be 1. Okay, that is the AND operator. In OR, either one is 1, it will be 1. If one of them is 1, it should be 1. See, 1, 0 is 1. This 1, 0, 0 and 1 is also 1, and this also should be 1, 0, 0 is 0. For example, phi operator AND, so phi is 0, 1, 0, 1, decimal, binary, decimal, binary. So when you put this operator here, I explained here, when either of the bit is 1, it will be 1. This is the result. This is the result for this one. Next one is exclusive OR. Meaning, now both should not be 1. One of the digits should be 1. So 0 and 1 is 1. If both are 1, it's 0. Both are 1, 0. That's the exclusive OR. That's the difference between OR and exclusive OR. 0, 1 will be 1. Next is right shift. These are very powerful operators. See, 2 greater than sign. Shift bits right. There are 2 operands. In all these things, there are 2 operands. NOT will have only 1 operand because not of something. 2 operands, so 1000 right shift 1 means 1000 is 8. So what happens is, see, 1000 is 8. When you shift by 1, this 1 goes here. So it becomes 0, 1, 0, 0. So the result of this operation is 4. If you shift 2 times, it becomes 2 because you are shifting these 2 digits, 0, 0, 1, 0. Same concept, you are shifting left. Shift bits 1 left, 2 operands. For example, 8, 2 shifts 1, what will become 0 will come here. So 0, 1, 0, 0 will be 4. NOT is by this symbol opposite. It has only single operand. NOT of something, for example, NOT of 0 will be 1, NOT of 1 will be 0. This is an introduction about the powerful bitwise operators in C language. I have videos in other languages, 10 other languages. Please watch them. Java, HTML, C++, everything is linked together. I have object-oriented videos and databases too. Thanks for watching. Hi, today we continue our journey with the C language. So far we have created around 300 videos, and C language itself will be like more than 25 videos. We started with the beginner level, intermediate. From today we'll go to advanced level for the C language. We have other videos for Java, C++, databases, check them out. Okay, let's jump into the C programming, advanced file management. How to handle files inside the C program. You can read from a file, you can write to a file, you can up and add more data to the file. Let's see how to perform all this within the program. It's very simple. It's not like hundreds of lines. It's only 3 lines of code. You won't believe it, but it's very easy. Any file, when you talk about C and Java, it's always about pointers to the file, pointers to the objects. So even in C files, we create pointers to the C file, which is an index array of pointers. So what can we do with C with all these files? We can create a file, open a file, read from a file, write to a file. Usually we define a file, we read from the file the data, do some manipulations using C statements, write to the file. For example, this is a template. File, it's the pointer. It's a reserved word for the C language. I define a variable, fptr1. When you say star, it's a pointer, So fptr1 equal, I'm saying open the file. Fopen, we put the file name and what mode we want to open the file. What is the mode? Write, append, read. Write to the file, append new data to the file. Add more data to the existing file which already has data. Reads from the file. Fclose, fptr1. See, only 3 lines of code. Okay, let's see how to write to a file. Same thing, I define a variable fptr2 pointer, fptr2 equal to fopen. This is the file, example1.txt. And then you put write. I want to write to the file. Here in the printf, we put fprintf fptr2 C file super. This is the message. Then I close the file. So initially the file is empty. Then we use the fprintf. In C language we use printf for regular ones. When it's files, fprintf. And then the message is displayed, f file super in the file. And this /n is for new line. It should be in here actually. Okay, let's see, append from the append actually to the file. So right now the file has 1 line. fptr2 equal to fopen of. Here we already closed the file, so you got to reopen again. Same file name. Here I am saying append. Here I said write. So fprintf fptr2. I am saying add to the file. Then close the pointer. So here too, second one is it's appending to the existing file. Add to file, same file. So this is the basic concept of C pointers to files. This is a very powerful feature. Similar thing is in Java. Java is actually pretty much written in C language. So a lot of similarities. In the next one, I'll create a video about how to read from the file and use the string functions. The get string. Please check my previous videos. There are like 10 string functions you can use. And here we are using with the files. Previously it's without files. Thanks for watching. Today we continue our journey with the C language pointers. Previously I have put a lot of videos about the C language, other languages. Please watch them. In one of the previous videos I talked about the concept of arrays and how we use pointers. Here I want to give more examples of the pointers and how the memory address is handled, the hexadecimal inside the computer's memory. Let's jump into the topic. C language pointers, memory address of a variable. Pointer is a variable where we store data. Actually the address of another variable. First we create pointers. We get the memory address and we use the reference operator ampersand. Pointer variable created with star operator. Same thing is used in like Java uses pointers, Python, so it's very powerful, Let's see an example here. An integer, flight num equal to 1010. Now it's a number. If I want to get the address where it's stored, I say integer star flight ptr equal to, see the ampersand sign, ampersand and then the variable name, flight number. What this does is it stores the address of this variable in this variable. 2 variables are there. One holds the flight number, another one holds the address where it stores the inside the computer. Let's see here. This is our PC or RAM memory, hexadecimal addresses. All addresses in computers are mostly hexadecimal. So 1010 is stored in this memory address. So, and if you go along here, another address, hello string variable is stored. Another address, super variable is stored. Again, string is an array of characters. Let's come back to here. So we are saying print the printf function. All these are functions in C. So we are telling the C compiler that it's %d flight number, display the data. See here 1010. Next we see display the address of that variable. See %p is pointers, %d is decimal, and %f is float, double. So you see here the address is printed here. Again, there are two ways to declare the pointers. One is you put like int star flight ptr equal to the ampersand and then flight number. It stores the address. Another way is you put the star on this variable itself. Int, no star here, star flight ptr. Both will display the same data address. Two ways to declare it. Let's come back here. What are the uses of the pointers? It reduces the code because you're interacting directly with the address where the value is stored. It's portable across different platforms. Windows, Linux, Mac. Speed, it's very fast because instead of using a variable, you're directly here connecting with the address. So execution will be faster. That's the power of the C language, Java, Python. And like this, I can create one function like this, and another person can use it. So it joins the library of C functions. There are like thousands of functions available. So you can write a large project and call all these functions to do your tasks. This is a brief intro about how pointers and how the memory addresses are used. Next video, I'm going to talk about how the functions and parameters work in C language. Thanks for watching.